Good day, we're Group 1, and we're here to present our system demo. I'm Clarence C. Cortina, and these are my co-presenters, Jasper Cadelinia, Lance Daniel Gonzalez, John Michael Darantinao, and David John Serato. To start things off, let's proceed with the DFA overview.
Uh, So we're going to be explaining the five tuples in DFA. So first tuple is the queue or the set of states. As you can see here, we have four states, namely Q1, Q2, Q3, and Q4. Next is the sigma, or also known as the alphabet. Here we can see that the alphabet we have R, 0, and 1. For the start state, which is represented by Q subscript 0, we have the start state of Q1. And for the final states, also known as the accepting states, we have two states, which are Q2 and Q4. And for the transitions, here we use a hash map in our code to represent the key and the value. The key here is represented within the open and close parentheses, such as the Q1 and Q comma 0, and the value will be Q2. In the code, we can see that there we can see the five tuples, which are the self dot states is equal states, and then the alphabet self dot alphabet, and the transitions start state and the accept states. For the demonstration of the app,
So for the demonstration of our program, first is the custom DFA generator. This is the generator where the users will input their all manually their DFA or the automaton will. So the first is the states separated by comma. So this is where the states were listed or inputted. Then the second is the alphabet, which is also separated by comma. This is defaulted to 0 and 1. Then the next is the start state. This is where the start of the state, the user will input the where their start state, so such as Q1. So then the accept state or the end state, also separated by comma. The example there is Q2, Q3. Then next is the transition table. The format um, that we input there is first is the current state, the second is the alphabet or the value, then the last is the end state. So as the example there, transition, which is copy and pasted. So as you can see there, then the user can input the strings, zeros or one. So this is like as the example there, 1001 or 1010. Then the app will generate a diff um, graph depending on the user's input. So there, that's the logic of the generation of um, the states that the program will need.
So we proceed to the different legends. First, the start state, then the next one is the states, and the third one is the accepting state. The next is the current accepting states, and next the current rejecting state. Next is the rejected end state.
Okay, going back to the transition table that has been generated by the user input. After simulating the DFA, we have a function that will create the graphical representation of the diagram basing on the table that was generated using the functions using the Python. So in the first step, we have a start state here, which is the step 1 to represent with a blue line here according to the legends above. And the next state, it goes from Q1 using the alphabet of 1, it goes to the current state of Q4. Next step, Q4. Next step, 1 here. From the Q4, using the alphabet of 1, the current state is now the Q3. And next part is to prove that the result has been accepted, the circle will be filled with color green. So that is the manual representation input of the user. So for the next module, for the random DFA generator.
Next feature of the system is a random DFA generator, wherein if the user is too lazy to input the number of states, what will be the accepting state or what will be the end state, then the user can choose a random size, like for instance 4, 5, and 6. So for example, let's input a number of 6 states. Then click the button for generate random DFA. So as we can see, the states will be generated into 6 states, which is Q1, Q2, Q3, Q4, Q5, and Q6. Then a random alphabet will be generated, which is 0 and 1. And the start state will be Q5, and the accepting states will be the Q2, Q3, Q1, Q6, and Q4. Next, the transition table will also be randomly generated. Now let's input a string. For instance, it's 1001 and click the simulate DFA. As we can see, upon clicking the generate DFA, it will generate a DFA diagram with the transition table along with the diagram itself. And the result is accept state.
Since we have generated a random DFA, the process is still the same. So for the first step here, we are going to start with the start state according to the legend above. And next input, the input character is 1, so we are expecting the state is going to the current state of Q3, which is correct. So next state, just follow the table diagram here on the right side of the program. Next state, which is now in the fourth step, and the result is accepted. So the next input string is going to be, oh god, one state, which the arrow pointing towards the current state of Q6. So the DFA simulator has proved that the state has been accepted. Now, for the next module, we are going to discuss about designing your own DFA using strings. So here, using the design your own DFA strings, we are going back first to the module for the review. So if the state is just using a variable, it will create a new state. It will create a new state pointing to another stage, which is in this example Q1 pointing to Q2. Now, if a star or a multiplication, the state is just going to point to itself using the value of a. However, if the state has detected that the operator is plus, just like in this example, the current state is going to point to the new state with a variable of a, and then the next state here is going to point to itself. Using here the close and open parentheses, both states A and B is going to point to the next state, which is Q2. And lastly, if A and another state, which is B, has been detected by the diagram, it will just create another new state. In this example, Q1 pointing to Q2 and Q2 pointing to Q3 using the variable of B. Now, using our program here, let's create a string to prove it. So, 1 star and 1 plus. If we design the DFA transition here, design DFA, wait for the generated transition here, we can copy this and put the transition here. Let's create the function here. Run the program, simulate DFA. Here, just like in our explained DFAs using the string, everything seems fine. So let's try to simulate this. First step, start state here. So this is going to the next state, which is still Q1 using the input character of 1. The next state, 0. And the string is accepted because it ended on the accept state, which is Q2. So that is the power of the string simulator generator using in our program. The program is working perfectly fine without any issues and technicalities. Thank you for listening.